Okay, area of a sector. The formula of the area of the sector is half times r squared times theta, the angle right there. The theta is in radians, so make sure you check that before you do calculation. All right, let's do a little bit of a proof here. I don't know whether you remember from the last video, which was the length of the arc, and I used a similar ratio proof. So I'm going to do the same here. So I'm going to call capital A as the area of the sector is a part of the area of the circle, so which is a pi r squared, equals the theta is part of the whole revolution, which is the 360, which is 2 pi. Okay, and then I'm timesing by pi r squared on both because I want the A to be my subject here. So theta 2 pi times 2 pi r squared, because if I times it, I'll get A by itself. And then, I made a mistake, it was a pi r squared. And cancel, I'm left with the 2 here, theta and r squared. So I'm going to go half times r squared times theta, just like that. Excellent. So now we can start the question. Okay, there's four parts in this question. First, find the area of the sector of a circle with a radius 5 centimeters if the angle subtended at the center is pi over 3, and write that answer in pi form. So, part A, find the area of sector. So we need to use the formula. Okay, here we go. What's the formula for the area of the sector? I'm going to just write it on here. Half times r squared times the theta. So I'm just going to write that there. And my radius is 5 centimeters. The theta is pi over 3. Pi over 3 in degrees will be 60 degrees, if you're just curious about that. Okay, so area equals half times, I'll push up a little, r is the 5 squared times the theta is a pi over 3. Now I want that to, the answer to be pi form, so I don't want to use a calculator in here for pi. I'm just going to leave it. So what I got is 25 pi over 6 centimeters squared. Okay, so that's what I've got. That's a part A. Part B. Part B, find the length of BC. Now, guys, BC is not the arc, it's the straight line we're talking about here. So I want, I'm going to sketch this here again. That's a 5 BCA pi over 3. So I want that. Now you can use sine rule here or cosine rule. I'm going to use cosine rule. Cosine rule is a bit simpler for me. Let's have a look at the formula for cosine rule. So cosine rule. C squared equals A squared plus B squared minus 2AB cos C. Therefore, I can actually do that square root straight away. And, you know, C has to be bigger than, so we don't have to worry about minus part. All right then, so I'm going to do, what I'm going to do is BC, isn't it? That's what we're looking for. So BC equals square root of the surrounding length, which is 5 squared plus 5 squared, minus 2, 5, and cos, now, before I put that in, I'm going to just write here, cos pi over 3 in the exact value, that's a cos 60. That's what we're looking for. Cos 60 is what? Half. Okay, so I'm going to put half here, or 0.5. Doesn't really matter what you do. And put that in your calculator, you will get 5. Nice. So that's centimeters. There you go. And part C, find the exact area of ABC. Okay. So pi over 3, 5, 5. So area of, remember using sine, it was half times A times B times sine C. So it'll be half times 5 times sine C. Okay, sine pi over 3. That's a sine 60 root 3 over 2. So, because it says exact area, so I'm going to go 25 root 3 over 4 centimeters squared. Okay, so that's my answer. Next one, we got D, part D. Part D says, hence find the exact area of shaded, I'll put it back here so you can see it. So hence find the exact area of the shaded minor segment. So that's all these little dots there, the shaded part of the segment. So how are we going to find that? I can see if we can find the area of sector and take away the area of triangle, which we just found, and then I'll get the leftover, which is the shaded part. Okay, so that's what I'm going to do. So here I'm going to do D. I'm going to go area of the shaded minor segment equals area of sector take away area of triangle ABC. Now remember, also we have to find the exact value, so I'm going to go area of a sector will be half times r squared times theta. Take away area of a triangle was from previous question. That's what I've got. Now r was 5 and theta was pi over 3. And I want to keep that as a exact value. So 25 pi over 6 minus 25. So I'm going to go to 24, cross multiply, 100 pi, 450, 3 because you times it. And I can see that common factor is about 50. You can leave it like that, but I just want to tidy it up a little bit. Squared. Okay, it's done. Now, next question, question 2. It says, arc PR, that's PR, subtends an angle 120 degrees at the center Q of a circle with radius 5 centimeters. Find the perimeter of sector PQR in corrected 2 decimal places. Okay, so we want these. Okay, that's what we want. Okay, so let's have a look at that arc PR. I'm going to call it as L. Okay, L. L equals r theta, and it's 5 times 120. Okay, so this is the part that I was talking about beforehand. We need to change this 120 into radians because it's in degrees. So what I'm going to do is 120 degrees into radians. So do you remember 180 degrees is equals pi? Okay, so I want to change into like a unitary method. I'm going to change to 1 pi by divided by 180. So it'll be pi over 180. And then times by 120, which is 120 pi over 180, which will be 2 pi over 3. So I'm going to convert that to there. So 5 times 2 pi over 3, that'll give me 10 pi over 3. So that's my length here, and I've got this. So perimeter of this sector is 2 radii and then the arc. So the perimeter equals 10 pi over 3, the arc plus radius plus radius. So 10 plus. And just put that in your calculator because I wanted to do 2 decimal places. Put that in, you'll get 20.47 centimeters. Okay, so that wasn't too bad. Now, question 3, the last question. Okay, so a wedge is cut so that its cross-sectional area is a sector of a circle with a radius of 12 centimeters and subtending an angle of pi over 4, which is 45 degrees at the center. Find the exact volume guys, so we don't want any decimals or anything like that, of the wedge. Okay, so let's have a look. What's the volume, guys? When you want to find the volume, is the area of the base times height, isn't it? So that's my height here. The area is my sector. So if I could just find area of base, which is the sector, half times r squared times the theta, and then times by the height is 4. This question is rather quite easy. Okay, so r is 12 squared times pi over 4, because that's what's given, and the 4, I'm going to cancel these. 12 squared is 144, pi over 2, half of the 144 with 72 pi centimeters cubed, guys, because it's a volume. So it is exact because it's in a pi form. Okay, well done, guys.